Today I am going to talk about the units which are frequently used in the oil and gas processing. In my opinion, unit conversion is fundamental, yet the most important part of any engineering discipline. Just before we start, I would like to tell you a story just to show you its significance. Let's go back to 1999 where NASA lost $125 million due to a tiny mistake. Let me tell you what happened exactly. NASA lost the Mars orbiter, because one team used metric units for calculation, while the other team didn't. I think this simple but effective story made you understand the importance of units. Let's start with temperature. There are plenty of temperature units, but I am only going to focus on 4 of them, namely, Kelvin, Celsius, Fahrenheit, Rankine. Luckily, we have this table which helps us to carry out temperature conversions. For example, you can convert Kelvin to Celsius, Fahrenheit to Rankine or Rankine to Kelvin. Let's convert 30 Rankine to Celsius. So we gonna start from Rankine and finds its intersection point with Celsius. Using the formula found in intersection point, we can carry out conversion. As a result, we find out that 30 degrees Rankine is equal to minus 256.48 degrees Celsius. In my opinion, temperature alongside with pressure is the most crucial and the most important parameter for chemical processes. Therefore, we need to pay extra attention to it. Let's have a glance at units. We have a very familiar unit here. You probably know kilopascal from school physics, which is equal to 1000 Pascal. Following this we have 1 bar, and it is equal to 100 kilopascal. Bar is very frequently used in chemical processes alongside with atmosphere and psi, which stands for pounds per square inch. At the bottom we can see millimeter mercury column, which is equal to 0.133 kilopascal. By using mentioned information, let's try to convert 5 psi to atmosphere. Unfortunately, here we don't see a direct conversion factor. But we can do it in the following way. First, we will convert psi to kilopascal by using our factor here. We gonna cancel out psi. Then, we will convert kilopascal to atmosphere by dividing it by 101.325 kilopascals. As a result, we get 0.34 atmospheres. Talking about pressure, I would like to point out a very important fact. The pressure can be given in terms of gauge pressure or absolute pressure. The main difference between these two concepts is reference point. Gauge pressure uses atmospheric pressure as its zero or reference point, while the absolute is referenced against perfect vacuum or absolute zero. To point out the difference, we usually put G or A to the end of the pressure units as it is shown here. Gauge pressure is preferred when the measured pressure is influenced by the changes in atmospheric pressure, whereas the absolute pressure is used when the measured pressure is not influenced by the changes in atmospheric pressure. To convert gauge pressure to atmospheric pressure, we simply add atmospheric pressure to gauge pressure like this. I hope you remember from school's physics class that what the volume is. But just to remind, I will give very brief and simple definition. The volume is the amount of a space that a substance or object occupies. Let's see its units. We know that 1 meter is equal to 100 centimeter, but there is a little difference here. There is a cube sign, therefore, we gonna write it as 10 in power of 6 meter cube. And it is the same for the relation between the meter and feet, as well. We have special units for volume here like barrel, liter US or UK gallon and of course standard cubic feet. Standard cubic feet is little bit different from the normal cubic feet since it refers to the value for volume taken at standard conditions. Standard cubic feet is generally used for gases since their volume is very sensitive to pressure and temperature. In the upcoming chapter you will get broader information about it. Let's try to convert 78 US gallon to centimeter cube. Again, we are not provided with a direct conversion factor, so we will do it step by step. First, by using this we gonna convert US gallon to barrel by dividing it by 42, and we cancel out gallons here. Following this, we're gonna convert barrel to meter cube by dividing it to conversion factor, and finally we are going to convert our meter cube to centimeter cube. Flow rate can be defined as the volume or the mass of the substance or fluid that passes per unit time. We have mass and volumetric flow rate. Each of them has different units. As it was suggested in the definition, flow rate is the volume per unit of time. We can take any unit of volume and divide it by any unit of time, and we do the same for the mass flow rate. Let me show you two very important units, especially for those who are working or planning to work in oil and gas industry. We have SCFD and barrel per day. I hope that SCF chunk is familiar to you from the previous part. Actually, SCFD is abbreviation for million standard cubic feet per day. Using million is a must here since we are talking about massive production capacities of oil and gas platforms, which cannot be expected to be a small number. So, if we want to show our number in neat and understandable way, it is good idea to eliminate zeros and substitute them with million. We usually use SCFD for gas and we have barrel per day for oil. We don't need to establish any standards for the volumetric flow rate of the oil because oil is generally in the liquid form and there are assumed to be incompressible. Let's convert 8 million standard cubic feet per day to standard cubic meter per hour. First, we will show our number in more clear way, by writing 10 in power of 6 instead of million, and writing units in clear form. Then we will convert feet to meter, and needless to say in cubic form, and cancel out feet. Following this, day will be converted to hour by dividing the number by 24. Finally, as a result we get 9,438.95 standard meter cube per hour. Here we have a parameter called API gravity, which is very important for oil and gas industry. API, or American Petroleum Institute gravity, is the measure of how heavy or the light petroleum liquid is compared to water. It can be found by dividing 141.5 and minus 131.5. Specific gravity, which is found by comparing the density of the fluid to that of water. Let's find the API gravity of oil, of which specific gravity is 0.85. It is actually a simple algebra where we just divide 141.5 by 0.85, and then subtract 131.5. As a result we get 34.9 degrees API. Let's talk about viscosity. As you remember, we have two types of viscosities, dynamic and kinematic. Viscosity can be simply defined as the resistance to flow. Dynamic viscosity is often given in terms of centipoise or sometimes Pascal multiplied by second. As you already know, kinematic viscosity is found by dividing dynamic viscosity by density. The unit of the kinematic viscosity is Stoke and often given in terms of centi-Stoke or centimeter square divided by seconds. Let's convert 1 centipoise to pound divided by feet divided by second. Well, at first glance it looks complicated because we cannot see this unit here. But actually this one is the unit of dynamic viscosity as well, and I am going to prove it. We know that the pressure is equal to the force divided by area, and we know their units. If we write this in terms of fundamental units and cancel out common factors, we are going to get this unit. Actually, it is Pascal given in terms of base units. We know that 1 centipoise is equal to 0.001 Pascal multiplied by second, and we apply the same thing here. We multiply Pascal by second and cancel out the common factor. And as result, we get this expression which is identical to that unit, but represented in different units system. Finally, we can carry out conversion. Firstly, we will convert kilogram to pound by dividing 0.001 by 0.454 kilogram, and cancel out kilograms. Then, I am going to convert meter to feet by multiplying the number by 0.305. As a result, we get 6.7 multiplied by 10 in power of minus 4 pound divided by feet multiplied by second. And finally, GOR. It is a specific unit used in oil and gas industry. The oil and gas ratio is defined as the ratio of the volume of gas comes out of solution to the volume of oil at standard conditions. The unit for the gas-oil ratio is simply the volume unit for gas divided by liquid. In most cases we have barrel here, but the upper part of the fraction may change, like standard meter cube, or standard feet cube, or million feet cube, and so on. Let's convert standard meter cube divided by barrel to standard feet cube divided by barrel. It is very simple. We are simply going to convert meter cube to feet cube. After cancelling out, we get 35.31 feet cube divided by barrels. That's it.